All right, chapter 1, review questions 1 through 4, extra credit, plant graphs, writing decimals as fractions, Pythagorean triples with special right triangles. Remember, the two special right triangles are 30, 60, 90, 45, 45, 90. There were 4, so what was it, 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17. 4 Pythagorean triples. We made a fifth by doing what? The 3, 4, 5. By multiplying it all by 2. Or multiplying it all by 3. Or multiplying it all by 4. Okay? And then multiplying the perfect squares between 1 and 25. What I'll do is I'll make a sheet. And all you'll have to do on that sheet is just fill in one of those. And I'll let that be extra credit for the chapter. The first 4 questions. Number 1, if the first thing that you have to do when you're asked to find whether a system has solutions or not, or to describe the system, is to do what to the equations? Okay, so if I were doing number 1 and I had 8x minus 12y equals negative 9, and I had the equation 6x plus 9y equals negative 7, what I want to do is I want to solve those equations. I want to solve those equations for y, or put them in what form is that called? Slope-intercept. Okay, they're in standard form now. Since they're in standard form now, I can take a look at them, and just by going, if the equation's positive, the slope is negative, or excuse me, if the equation's negative, the slope is positive, and I know it's just 8 over 12. If it's 8 over 12, that reduces to 2/3. Okay, so I know that this slope, when I solve it for y, I have a good idea, excuse me, not 2/3, 3/2, that I'm going to get, well, I guess it is 2/3. 8 over 12 is 2/3, my bad. So y equals 2/3 x plus 3/4. So if I'm going to answer the question, how many solutions the system has, I got to figure out whether this solution is independent, dependent, or inconsistent. To do that, I compare the slopes and the y-intercepts. So I've got to find the slopes and y-intercepts. And when I find the slopes and y-intercepts, I end up with different slopes. Guys, as soon as you end up with different slopes, you know it's independent, because you know those lines cross in how many points? So that's why the answer to number 1 is B. All right, now, somebody in my 7th period class said, Coach Hill, are these lines perpendicular? Because it seems like to me one of the slopes is positive and one of the slopes is negative. Remember, from our previous studies of linear equation, if they have parallel lines, the slopes are the same. If they have perpendicular lines, it's not just they're opposite of each other, but you have to do 2 things to them. Do you remember what this? It's the negative and what else? No, not the positive. Reciprocal. So if this was 2/3 and this had been negative 3/2, not only would they intersect in the one point, but they would also be perpendicular to one another. These aren't. They just intersect. They just cross, and so they have one solution. By the way, want to make sure we don't mess this concept up. It has one solution that's made up of a x and a y. Yesterday, we were working equations that had 3 solutions, x, y, z, or excuse me, 3 parts to it, but it's still only one solution. Guys, the only answers that you would ever get for this problem are 0, 1, and infinitely many. You would never get 2 as a solution, because there's no way that a linear equation can cross in 2 places. Questions about number 1 there? All right. Number 2 is basically the same question, but this time instead of saying 0, inconsistent, 1, independent or infinitely many dependent, it says those words. So guys, this is the same question. So I go about solving it the same exact way. So that means I'm going to have to take these two equations and solve them for y. So when I solve it for y, that means get y by itself, solve for, or divide by negative 30. And so y equals 45 over 30 is 3 halves x plus 30, 30. So I solved it for x. The equation's in standard form. I've been trying to get some of you guys to see if I have an equation in standard form, and the equation is negative, the slope will end up being positive. And you just take the coefficients right there. That coefficient is a, that coefficient is b. So you just take an equation that's in standard form, and the slope is always the opposite. So I know before I ever started this equation, just from looking at it, guys, just from looking at the equation, how it's set up, I have in my mind that the slope is going to be 45 over 30. What is 45 over 30 reduced to? Okay, so there it is. It happens. Now, the reason I'm getting you to do this is, and certainly, if you know where you're going, you have a lot better chance of finding out whether you got there to the right place or not. When the bell rings at the end of second period, we know to go to third period. I have some freshmen that don't quite understand that yet, so when the bell rings, they're not quite sure where to go. So it makes it tough to know when they get there. Guys, when you start an equation, if you have an idea that you know where it is that you're going to end up at, it helps you a lot. By the way, is this equation in standard form?
Yes.
Okay, we think it is, but it's not.
It's got a negative.
That's right. Remember, A has to be positive for something to be in standard form. So you wouldn't have to do this per se, but if I multiplied through a negative and said 12x minus 8y equals negative 24, then you would have an equation that's negative, so you know the slope's going to end up being positive. Let's look and see what happens. Guys, don't let me make this mistake. 90 over 30 is 3. I should have put a 3 right there. So anyway, 8y equals 12x plus 24. Divide by what?
8.
Divide by 8. And so y equals 3 halves x plus 3. So again, these two equations have the same slope. They have the same y-intercept. So even though they're camouflaged, even though they look different because they have the same slope, the same y-intercept, they're the same line. So we say they're the same line by saying it's C, consistent and dependent. Questions? All right. It says right answer is show the work provided, solve the system by graphing. So that means I'm going to have to take each one of these and solve it for y. So negative 2y equals negative 4x minus 12. So y equals negative 4 over negative 2 plus 6. So y equals 2x plus 6. So I've got to graph that line on this grid, and I got to graph negative 2x plus 3y equals 6. 3y equals 2x plus 6. Divide by 3. Y equals 2/3 x plus 2. All right, again, under the idea that I'm going to go to the graph, are these two lines going to intersect? Yeah, I know they're going to intersect. Why is it I know they're going to intersect? They have different slopes. Since they have different slopes, I know, based on the previous question, I know this is an example of a consistent and independent system. So, again, before I ever start graphing this problem, I had a good idea of what my answer is going to be. So I go to 6, then up 2 and over 1, up 2 and over 1. I draw that graphing. In this particular problem, it doesn't happen. But in a testing situation, make sure you remember if the slope is negative, you go the other way. People mess that up from time to time.
Coach, are we testing?
Yes. Okay, and so y equals 2/3 x plus 2. I got a graph, so there's 2, up 2 over 3, down 2, left 3, down 2, left 3. So it looks like they intersect right there. So 1, 2, 3, 4, 5, 1, 2. So it looks like to me that it's 5, -2. Okay, hold on. Just don't panic. Let me make sure 5 -2 is the problem. It may not be. But guys, you don't know that until you go 20 plus, that gives me 16. That's not the right answer. -10, I'll plug in a 5. -10 minus 6 is -16. It's supposed to give me 6, guys. It doesn't. So I've got something wrong over here, and I got to go figure out where my mistake is. Does anybody see where I made my mistake?
I did.
Go.
Well, you crossed them at the wrong spot. They didn't touch right there.
They didn't touch right there, did they?
Nope.
So I had this line that had a slope of down 2 over 1, down 2 over 1, and this equation here. So where do they cross at?
-3, 0.
Okay. So here's -3, 0. So I must have gone up too far to begin with. Let's see if I can graph these better. 6. My slope is 2, down 2 over 1, down 2 over 1, down 2 over 1. There we go. And y equals 2/3 x plus 2. So here's plus 2. Down 2 over 3, and so now they cross in a correct place. Point being, I now know the answer, or I now think the answer is -3, 0. Watch what happens this time. This time when I plug 4 times -3, what does that give me? -12. Minus 0 is -12, which is what it's supposed to be. -2 times -3 is +6. -2 times +3 is 6. 6 is, guys, in other words, this point solves what? Both equations. My original answer, I got in a hurry, I got an answer, I plugged it in, it didn't work. A lot of times, you guys will get an answer and just put it up there and assume that it's not, guys, you don't have to do that. You take the point and plug it in, and it'll solve the equation. The same thing happened yesterday when I went. Twice as many people pledged $25 as $50. So if I let X be $25 and Y be $50 pledges, X is twice Y. So X equals twice as many that pledge 25. So there's more people that's going to pledge 25. My other equation is 25x plus 50y equals 18,000. Okay, plug in my 2y for x, and that gives me 50y plus 50y equals 18,000. 100y divide by 100. Y is 180. If y is 180, according to this equation right here, if I put a 180 in for y, x is now 360. And like the problem says, x is twice y. Yesterday, when I originally tried that, I had y as twice x, and this worked out backwards. But more importantly, when I plugged it back into this original equation, it didn't give me $18,000. This time, when I multiply 25 times 360, I get 9,000. Guys, take your calculator, do 25 times 360, hit enter, you'll see it's 9,000. And then 50 times 180, because 5 times 18 is 900. 180 times 50 is 9,000. And 9,000 plus 9,000 is 18,000.
Because
If I plug 180 into the wrong one, if I plug 180 and only multiply it by 25, it doesn't give me what I'm looking for. It's too little. Again, what's important that you understand about the process is when you plug the equation back in, it works.